J.N.K. Singh. I have been in data center industry for more than 30 years and fortunate enough to get involved in complete data center life cycle. We have built more than 100 plus data center in India and outside. And recently we started a company called Data Center Guru, which has a key goal of plugging in the gap which data center industry is having and having to overcome the challenges which this high growing industry is facing today. So we have certain initiatives around skill development on data centers, knowledge sharing and collaborating platform, apart from the services what we provide to address those challenges which industry is facing. So before inviting my panelists, I would like to thank ISHRAE CoOL Conclave organizing committee for inviting me to this event and adding a data center track separately, which I will talk later on once our panelist comes over here. So I would like to invite Mr. Sudipta Sanyal on the stage, please. Mr. Manoj Kapil, Mr. Jaybalan, Mr. Pankaj Wadhwa, Mr. Alok Rajput, and Mr. Frank Miyus. Mr. Amit Kakkar, sorry. आपको कैसे भूल गया मैं? So, before I start the discussion, most of the panelists over here are from data center industry, and as this is a CoOL Conclave and this is the first data center track which has been introduced here, so I would like to have a brief introduction of all of our esteemed panelists, starting from Mr. Frank. Thank you.
Yeah, good afternoon to everyone. My name is Frank Mewes. I'm coming from KSB. We are producing pumps and valves. I'm located in Germany in our headquarters, and I'm responsible for the ISHRAE business development and regional sales support.
Yeah. Good afternoon all. I am Amit Kakkar, and I am Chief Engineer, Public Works Department, Government of Rajasthan. I am BTech in electrical, MTech in mechanical, absorbed in civil department and used to work for IT department. So basically I am a man of project management, and because of my posting in Department of IT, I did certain courses in IT like CDCP and ETD. So I will talk just about that things. So it's all about me. Thank you.
Good afternoon, everyone. My name is Alok Rajput. I am from Vertiv. I take care thermal business for India and Greater India. Associated with data center industry for last, I think, 26 years, and mostly cooling part of it.
Yeah, good afternoon. I am Pankaj Wadhwa. I am an architect, and now 36 years into practice, 30 years now into data centers. And we built data centers from 700 kilowatt now to 100 megawatt data center. So we'll discuss it further. Thanks.
Good afternoon, everyone. Myself, Jaybalan. I am lead engineering for PDG India, and I have been in industry for 25 years and working in data center for almost one and a half decades now. Thanks for being here.
Good afternoon, everyone. Myself, Manoj Kumar Kapil. I represent company called DTSS. It's a part of SIS Group Enterprise Company. We are into security solutions, cash logistics, and my division taking care of integrated facility management, covering all major sectors. And past almost 20 years now, I've been associated with data center operations, design, and projects.
Good afternoon. My name is Sudipto Sanyal. In fact, I am a retired person, but I work as an advisor with a IT company, Orion Pro, and my detailed introduction is there. Thank you.
I'm Richie Mittal. I'm 42 years young in this industry, in HVAC only, and I'm very young for this data center industry. Thank you.
Thank you very much. So, yes, this is the first track in CoOL Conclave for data center. So, we'll just set the context of this, why we are talking about sustainable data center design, build and operate, and what should be the way forward for digital India. So data center industry is not new. It has evolved from last 25 years, from small server rooms of 100 kilowatt to 100 megawatt capacity data centers, even 300, 500 megawatt data center parks. So within these years, what we see currently, if we talk about specifically after 2016-17, we are experiencing a very high speed or rapid growth around data centers. If we talk about 2017 or 18, we were around 350 megawatt capacity. When we talk 350 megawatt, it is IT load of the data center. Currently, when we measured in April 2025, we already touch 1,200 megawatt capacity. And this capacity is expected to cross 2,000 megawatt by end of 2026. And when we talk about a larger view on 2030, which we are going to touch around 4,000 megawatts. That's the size and scale of data center growth which we are talking about. And why we are talking about so much on the sustainability aspect of it is typically as you consume power, because data center is one of the power guzzler. If you can imagine the entire hotel, how much power it must be consuming. One data center building consumes around 50 megawatt. So around 30 megawatt of IT load consumes around 50 megawatt of utility load. So for how much normal buildings this power consumption is required. And that is the reason it is very, very important to look at the aspect of the sustainability of the data centers. Second aspect is there has been lot of dynamism in the technological changes. I think from study itself, we are hearing about AI. AI is something which is not on the words now. Adaptation of AI is already in place. And the workload which requires, or the power consumed by the workload, or the heat exhibited by the workloads are so high. It is around, I will say 10 to 20 times whatever the current load which we have. So we are discussing, fortunately, we have panel across the industry, and we have people from data center operator side who design, build and operate data centers. We have people from data center consulting firms who design data centers, which we have people from OEMs who supply such products and solutions around the data centers. And we also have representation from operation side. Normally, operation and management plays a very, very important role when it comes to data center. So with this, I would like to start the discussion, and I will go back to Jay Balan first, because he is the operator side. And when we talk about these such demands which is being read in the newspapers, articles in day and day out, what is that thing which you are really experiencing in your company's experience, or you are experiencing in terms of such demands of data center? Secondly, demands on the AI perspective or the change those technologies and supporting those technologies. And then what is the issue which we are facing from the sustainability perspective?
Sure. Thanks, Mr. NK, and I'm glad to be here, part of this panel discussions. And it's a very rare, you happen to see the panel having a users, which is a design and the operator, build and operate, and you have consultant who develop the concepts and work with the customers. And we also have got a OEMs who supports the products, who supply and being a part of the data center journey. And also we got the operations as well. So glad to be here. I mean, while talking about the AI and the demand, I like to just give a kind of perspective how the data center evolved over a period of a decade. Since most of us, I'm sure everybody aware, like in 1990s when you started talking, you might be using the pager and started using a 2G, right? That was what everybody started seeing a mobile, and you start paying money for incoming calls and so on and so on. And now within no time of just 1.5 decade, we are into the 5G and we are about into a 6G, and also talking about the satellite net. So similarly, when you talk about data center, as NK mentioned, like it started from a 1 megawatt as a campus, as a whole building. I mean, if somebody has a 1 megawatt data center, it used to be a very big thing, 2010. And now we talk about 100 megawatt as a single building, especially when this data center, this particular hall, if we talk about, this data center, this hall, I mean, to 4 or 5 floors put together, can consume 150 megawatt facility load. When I mean that means 100 megawatt kind of capacity. Having said that, how it's evolved in a data center, we normally talk about the rack, which is a 600 by 1200 is a dimensional, 2 feet by 4 feet, that's a rack. We used to experience, give a solution to 2 kilowatt starting from 2010 and on. And then that's what we used to see the retail as a customer. Retails, enterprise customer used to do a 2 kilowatt, 4 kilowatt kind of customer. And in 2015, you might have started experiencing the cloud player entering into the industries, and they started coming with a little higher density of 7 kilowatt, 10 kilowatt kind of stuff. And obviously, AI is not something new for us. AI has been for long in our journey. Now we're talking about next generation of AI which we're talking about. So the 2 kilowatt density racks, which we started talking about 2010, now you experience the rack density, average rack density is talking about 25 to 40 kilowatts average density rack. And we recently commissioned delivered infrastructure solution to a customer. It supports 137 kilowatt rack with the solution in one of our facilities. That means 600 by 1200, it was consuming 200 kilowatt earlier, and now we delivered 137 kilowatt. And recently I was talking to a customer, and I was I'm astonished to hear what customers spoke about. The fact is that he was explaining about 500 kilowatt chassis. I mean, a small footprint, maybe could be around 1.2 or 2 meter chassis rack. He's talking about 500 kilowatt power consumption. That means one small chassis expected to, we need to deliver or support close to 750 kilowatt facility load. So that's how that industry, evolved along with the technology what we see. So it's a massive, shift. So next generation AI, which we expect, we're talking about a lot of training modules, middle and small and medium and large modules. That means we are expecting the demand to grow and grow and grow. Obviously we have the challenges in terms of delivering capacity of the small footprint, high density racks, high power consumption. And in the data center campus, nowadays we don't talk about 2 megawatt, 20 kilo megawatt. We talk about 500 megawatt campus or 1 gigawatt campus in Mumbai, kind of cities. So this is a massive, it is not just a change, but it's a completely major shift in a data center industry which we have been witnessing.
Thank you, Javalan. So that means you are endorsing that you are really experiencing such kind of demands, such kind of technological disruptions which is coming in the industry, and we need to be ready for that. So now coming back to Pankaj, who has been in data center design and engineering. So obviously when such challenges are thrown on us, when we used to design a data center for 6 kilowatt per rack or 10 kilowatt per rack, 15 kilowatt per rack, suddenly it comes down to 100 odd or even 200 kilowatt per rack. So how do you see such thing in the changes in the design considerations which we have looked at holistically for all the building blocks of the data centers?
Yeah, so holistically speaking, I would first go to the site selection part. I think that's the most important thing, because data centers these days are really power guzzlers. They also create a lot of pollution once the DGs are tested. Even if the power at the back end is good, we discharge lakhs of kgs of carbon dioxide or the other gases. So I think we should be moving the data centers with such high capacities to the powers where the power source is, not in tier 1 cities, because we were creating urban heat islands there. And also when we have too many data centers in proximity, then we are carrying heat from one data center to another. So the efficiency of your chiller system and everything goes down. And that's one major challenge. Now with the loads coming up, the building loading has gone up from initially 1000 kgs to 1500 kg. Now it is 2500 kg per square meter. The height of the building was 4 meters, then went to 5 meters, and now we are talking of 8.5 meters, where just our friend Mr. Rahul was displaying. So that's the solution with those water systems and all. The heights we are talking is 8.5 meters. That's huge height to manage and all. So this is the kind of challenges, and plus evacuation of services, evacuation of data. In our lifetime, a single person would now be probably consuming a zettabyte of data. So once you are evacuating from AI systems such heavy, data, you really need to focus on the master plan. You need space around the building to run all your services, because already the services are too many and they are all cramped up. And we need to have a green cover all around data centers, because ultimately to avoid the heat island effect and also having a negative impact on the rest of the environment, I think that's the necessity and should be made compulsory also. Thanks.
Thanks, Pankaj. As rightly said, I mean, for the audience, what I'm trying to tell, data center is nothing but it is also a type of building, like if you have got hospital, commercial building, residential buildings. Based on the application of the building, the configuration and the design of the buildings are different from core and shell perspective and also from the MEP perspective. Absolutely different, because you need to have high level of reliability, and obviously as you are going up on the power consumptions, high PUE and other related initiatives which needs to be taken care of. So I am not dwelling into other building blocks of the data center, because this particular event is concentrated around HVAC and coolness aspect of it. So I'll go back to Sudipta. And till now we did not have much of issue when it came to cooling, even power distribution and all. But with adaptation of AI and AI workloads coming, there has been drastically change in the cooling technologies and how it can be supported. Sudipta, you can be able to elaborate more on that. How we are able to sustain or overcome those challenges which is thrown by AI on data centers.
Yeah, good afternoon. AI is inevitable. Okay. Just what I am saying that AI is inevitable. I recall my journey when PC was also not used. Now, in 1990s, when PC came, there was a lot of opposition from the trade unions. But this opposition was not only in developing countries like us, but it was even in USA. And I remember there was an article in Forbes magazine. It says, dig more coal, PC is coming. That article was there. So in that context, I am saying that AI increases definitely the energy footprint. As Jay Alan said, per rack density. Earlier we were talking about only 2 kilowatt racks.
Keep your mic near.
2 kilowatt racks. In the cloud applications, actually it is going to be around, let's say, 10 to 20 kilowatt. Whereas in the AI, the rack density could be as high as 50 kilowatt to 125 kilowatt. As on today I am talking about, because NVIDIA is bringing in GPU with a very high TDP, we call it actually, thermal design power, and each chip is a 1600 watt. So within a one use space actually, you can accommodate 4 such chips. And the total power consumption along with the CPU as well as the memory, it will go to approximately 6.5 kilowatt. So you can imagine how if in a 42U rack, one U itself is consuming approximately 6.5 kilowatt. So everything it depends on architecture. So in the future we may encounter a rack with a density as high as 600 kilowatt or even 1 megawatt. That is a kind of rack density. Now coming back to the energy footprint in India, presently data center consumes around 0.5% energy of the total energy what is produced in India, and it is expected with AI and cloud adoption by 2030 it will go to approximately 1.5%, and total your demand, it will be 5 gigawatt. So this is a humongous challenge actually. If you look at within this such a small span period, it is nearly increasing 5 times. Now what will be impact on the cooling basically? Okay, now cooling till today, these are air-cooled racks, air-cooled servers. We are taking care of with the perimeter cooling, localized cooling. Sometimes we are adopting rear door kind of a cooling. But with such a high energy footprint, we cannot cool it by air cooling. We have to adopt liquid cooling. Now with the liquid cooling, one of the advantages, as you know, water is most efficient media. It is 3,500 times more efficient than air. Okay, so it can take a lot of the heat basically. So the challenge is basically that initially day one it will not be all liquid cooled racks. It will be probably few racks will migrate to the liquid cooled racks, and majority probably would be air cooled. The solution need to be in such way that it has to be a modular, scalable solution so that we can cool with the present existing system, like 1 rack or 2 rack of liquid cooling, like we have a air-assisted liquid cooling system. Probably we have to start with that. Then as we migrate actually, then probably we have to use back-end infrastructure like chiller for cooling both air and liquid cooled server. One thing we have to keep in mind that all will not be liquid cooled. There are certain IT components cannot be, as on today I am talking about, like storage, cannot be cooled by liquid. Okay, networking, there are some difficulties in cooling. So as on today, we expect that 80% of the devices it will be liquid cooled and 20% it will be air cooled. But this planning is, day one it will not come 80 and 20. So the planning becomes very dynamic actually. That is one of the biggest challenge. That day one it may be 10%, maybe after 5 years it could be 50%. So how to scale that, how to make it modular, that will be the biggest challenge. Another challenge is here, AI is throwing a lot of instability in the system. AI load varies too much. Like initially during learning phase, AI consumes a lot of energy. Like when we are learning, we spend a lot of energy. But when interference phase actually, when AI is used, the energy consumption reduced drastically. So there is a big variability it comes. Now everybody talks about sustainability, we are going for a renewable, we are going for a wind. Renewable and wind also brings in a lot of instability in the system. And on top of that, if the AI comes in, then it will also induct a lot of instability in the system. So how to take care of this, all this infrastructure, that will be a design. And third, actually, I think Pankaj has said one thing, this AI racks will be very heavy racks. Right. And it will be 3000 kg single rack. So earlier, probably the floor load we used to design based on 1500 kg. Now we have to design based on 3000 kg per square meter. So these are the challenges.
Thank you. Thank you, Sridipta. As you rightly said, the entire cooling technology is going to change. Where we used to have air cooling in the data center, now we need to have a hybrid cooling. As you rightly said, 20% of the hardwares in ICT or servers or storage can't be cooled by those liquid cooling technology. You need to have air cooling. So there has to be air cooling. So as he defined the percentage also, around 20% of the cooling has to be done by the air and 80% has to be done by the chip. Most important aspect of the entire design thing is, normally when you build an infrastructure which lasts for 20 years, more than 20 years, and when you look at the technologically life cycle changes, it changes every 3 to 5 years. So how do you future proof your data center so that whatever technological changes which comes into the data center, you can be able to deploy without or with minimum changes in the infrastructure. That's the key thing what we look at. Now I am going back to Alok, who is the OEM. So when we talk about cooling technology, liquid cooling, you might have heard direct to chip cooling or immersion cooling, which is the only media which can cool such kind of high density power requirements or heats. So because volume of air which is required within that short space you can be able to generate. So is this technology maturity level, because when you talk about this liquid cooling is not a new technology, but it was in a cold storage for a couple of decades. Now such requirement has come back and deployment of such kind of technology already is in progress. So people has got in mind how do we build up the confidence, what is that maturity level of such technology or the installation which goes smoothly and we get that level of performance without any compromise. Alok.
Yeah, thanks NK. I think it's very interesting thing. Before I jump into the explanation of this, we need to understand few of the things. We heard about a couple of megawatts data centers, one building of 100 megawatt, 150 megawatt. We need to understand the fundamentals of it, how and where it is coming from. It is actually coming from high compute demand, which is increasing day by day. Now, just for an example, we all use GPT, Chat GPT. Now we just type something and I think in few seconds, maybe 3 seconds or 4 seconds, you get entire answer. And then you rephrase it and another 3 seconds, it gives you entire explanation. with proper paragraph, with proper explanations. And the more you deep dive the question, the more you get deep dive answer. Now, how does it function? Whatever question we put into Chat GPT, it goes back to US data center, OpenAI data center, which has been built with approximately $450 million. Okay, the kind of investment, think about, and therein they have been using all NVIDIA servers, high compute servers. That servers and chips, GPUs, CPUs, they work immediately within nanoseconds and they give you the answer. So this is something high compute which is changing lives, and this high compute is actually creating AI workloads. And because of the AI workloads, these data centers of megawatts is coming to the picture. Now, interesting thing, the driver for this change in the technology, what NK and everybody, Mr. Sanyal has explained, liquid cooling, is changed now. It's not decided by the OEM, it's not decided by consultant, it's not decided by even end user. All these is coming from chip manufacturers, NVIDIA, AMD, Intel. They are the first one to initiate these and launch the chips, the GPUs. And they define whether it is air cooled or liquid cooled, and that's how further it goes to the server manufacturer, wherein the server manufacturer like Dell, HP, IBM, Lenovo, they integrate with their racks, and that racks as a solution goes to the end customer. Now end customer, of course, he is the decision maker. He will decide whether he has to use it based on scalability, price, and business case. But if you look at the whole chain, he has again limited choice. It is again driven by chip manufacturer. One of the important element here is OEMs, who has to work with these people for server manufacturer, for chip manufacturer, not only to ensure that they meet the new requirements for new technologies, but also have to optimize the solution. So this is the basic thing which is driving the whole thing. Now coming to liquid cooling, it's not a new concept, it's very old concept. Whether we talk about DCLC or whether we talk about immersion cooling, it has been there for I think 10 to 15 years running, but we need to understand that was primarily based for HPC application. But now, more than HPC application, we are talking about AI, as I explained. So it is going to be used everywhere. Now, whether it is be 100%, as Mr. Sanyal said, there is a question mark, maybe yes, maybe not. Ideally, it would coexist with the air, around 70-20%. As a OEM, if I understand the question correctly, the readiness, yes, we are ready. We have been deployed number of data centers with liquid cooling, both the solutions, direct to chip liquid cooling as well as immersion cooling. And we have been closely working with NVIDIA and Intel. There is a program in the US called CoOL Chip program. It has been sanctioned around $40 million grant, wherein they are working along with the universities also in the US, and they have been working for future kind of loads. As everybody talked about 500 kilowatt per rack, going to 1 meg per rack. And I think most of us have heard NVIDIA talking about new platforms which will bring more heat and heat. So we are ready. There are few things which everybody is learning in the phase, but the deployments are in the process and we have been doing it. We are also working on new technologies wherein further optimization of energy can be done through elevating temperatures on the chillers as much as high, because new platforms might have much higher throttling temperatures and it can ask for maybe 40-45 degree temperature of data centers in future. So we are working on that. Thanks, Alok.
Thanks, Alok. Thanks for the briefing. I will go back to Frank. As you have also been contributing in terms of HVAC in the data center, there are certain products and the components which goes into that. So how your solutions are being impacted, or how you are dealing with such demands or the changes?
Thank you. I see what was said at the beginning. The challenges are coming: sustainability, energy saving, service life, easy to maintain, etc., etc. These are requirements coming to pumps, and for me the only solution is more intelligence bring to the pump. Not only cast iron with an impeller turning, we must have new motors, better efficiency. The intelligence must take care that the pump is doing what the system needs. Yeah, maybe automatic adjustment and so on. In addition, we see the possibility more and more that the pump says, hey, I have a problem. Yeah, you need the pumps for cooling. When they are stopping, you have a problem. So we must take care that you have maintenance, always predictive maintenance, that you know, okay, now we have to take care, something going wrong. And for us, we are not looking only to this application. We have the rack cooling, we have the cooling of the building, we have as well the power generation for the data center. We learn more and more is the idea to have small atomic power stations next to this data center. For this we need as well the pumps. And in some areas it's more and more an idea, what should we do with all the heat we are generating? And in Europe we come to the idea, take it as district heating. So this transfer must be used as well. And so the challenge is, what I say, bring more intelligence to the product. And you want to have it cheap, by the way. That's as well very important. So, and we must bring as well the idea to the customer, to the end user, to the designer, look to the life cycle cost. Not only investment. The investment is one most discussed issue, but the costs for a product is over the lifetime. And when you have a product which fits good to your requirement, is working in the optimum and not in part load, overload, then you extend the lifetime, and with speed control you can adjust or you can reduce your energy costs. And that is for us a challenge for the next years, and not only for the small pumps, up to bigger pumps. And for us it's good thing, it is as well interesting for buildings in general. It's not only for this application, because in a hospital, in a hotel or whatever, we have all the same requirements.
So you are there across the sector, including data center. Great, thank you. Then I'll go back to Amit Kakkarji. He has been instrumental in designing and building and certifying India's largest government Tier 4 certified data center in Jaipur. And I would like to hear from him in terms of the key, his experience, the positive and the challenges, and how did he overcome overall. So your sharing would be really the practical one. Thank you.
Thank you. Thank you. The question which Mr. N.K. Singh Saab has asked me is my experience with the Tier 4 data center, I think so. You are asking for that. Basically, I will like to tell you that Government of Rajasthan was started installing data centers right from the year 2005. And at that time we constructed 140 rack data center. Then in 2010-15 we upgraded it to 80 rack data center, and as you said, in the year 2018 Rajasthan government constructed first world's, most of the people say it was the world's first Tier 4 data center as per uptime standards. Most of the countries were not having, they were having in a private sector but not in a government sector. So in this journey of of 20 years, and what I have found that when we constructed first data center in the year 2005, then there were no terms, most of the terms were not there. Like in the year 2017-18 when we were designing that, we used to think of designing it with reference to PUE. Now today when we are sitting in this forum, other than PUE, we are using the terms like CUE, WUE, and others. What I have seen and what most of the people have discussed here, that the life of a particular data center is not much. In the last 20-25 years, what I have seen that the data center life is very small. If you think of any type of data center constructing this day, because of the development of technologies in the IT sector, in the air conditioning sector, in the power sector, what we have realized that they become redundant within 10 years. The technology changes so fast. So when we constructed this data center in the year 2018, the best thing about that data center was that it was constructed in a record period of 18 months. And all the stakeholders worked very hard, including you, Sanyal Sahab was there and others, Valte was there and other things. But now when we are, the government of Rajasthan is thinking of making another data center, then what I realize in the year 2025, that what we constructed in the year 2018 is getting redundant because of the use of AI, because of the use of deep data analysis and other blockchains and other things. So ये मेरे दिमाग में एक बहुत वो आता है कि इतना डेवलपमेंट हो रहा है, हर फील्ड में हो रहा है, एंड उसकी वजह से जो हम अभी देखते हैं कि हमारी जो हमें सस्टेनेबिलिटी, अवेलेबिलिटी, रिलायबिलिटी, ग्रीन बिल्डिंग्स, ग्रीन थिंग्स, ये सब हम इसकी बातें करते हैं, लेकिन ये बहुत एक चैलेंजिंग है और इसको मीट आउट करना इज अगेन अ वेरी चैलेंज. जैसे वाधवा साहब ने बताया अभी कि एवरीथिंग, यू नो, द एंटायर थिंग ऑफ डेटा सेंटर गेट्स चेंज when the power requirement and air conditioning requirements gets changes. Initially we used to think of rack requirement of about 6 kilowatt, then it grows up to 9 kilowatt. Last year I heard it for 25 kilowatt, then 6 months before I heard it for 125 kilowatt, and today in this platform I am hearing that per kilowatt rack load is going about 500 kilowatt. So you see the challenges which is coming, and this entire industry has to think what they are thinking today, what they are designing, and what outcome it will come when the facility will be constructed. So it's a very important thing we should think of.
Yes, that's very, very good experience which we have shared, and that's the reason future-proofing of the design is very, very important. When you have a future-proof design, then such kind of technological deployment becomes much easier, because you design the entire infrastructure based on that. And I would like to say that even today in the industry there is no benchmark or matrices which measures scalability and flexibility of your data center. If you don't measure the scalability and the flexibility of your data center, how do you meet those challenges of flexibility and scalability? So yes, these are the things, and now this future proofing concept or design which is coming, and it is going to help the industry. Now I am coming back to Manoj. As you take care of operation and management of the data center, and if I look at the entire world, developed, middle, underdeveloped, I see the facility management in our part of the world is still at novice stage. We have to go long way to make our operation and management program technology and process and technology centric. So currently, how you are doing the operation and management, up to what level your maturity level has come, and what is the plan to move further?
Yeah, thanks, Enke. Bringing this very valued point now. When it comes to data center operation and maintenance management, we come through the very last value chain: design, construction, and operation and maintenance. And when it comes to 3 M's, money, machines, and manpower, we also manage the most critical aspects, manpower. At this point of time, close to 50,000 employee plus base in India we cater, and on technical services is approximately 7,000 plus resources we have deployed. When it comes to data center specific requirement, customer, the maturity level in the scope point of view, the delivery and deliverables point of view is very much improved, is available. The only aspects, the deploying the resources which are having relevant experience. When I say relevant experience, we had huge number of technical resources managing manufacturing, IT, ISS, hospitality, other sector, but customer from the data center domain, they need a relevant resources. Why? From storage to compute journey, your compute power is taking very heavy toll, your facilities is become very dynamic, cooling requirement, electrical power requirement has changed up. So they need smart, relevant, experienced guy who can manage. But the challenge we are having, the cost. The availability of relevant experience and the cost they are expecting. They still comparing the relevant DC experienced guy with a conventional DG operator, HVAC operator, DMS operator. So this is a challenge. So what we are trying to do, we are trying to create a employee hiring and retainer program, excellent. So we keep motivating employee, but the money factor is there. And another challenge we are having, all these data centers are coming up in a very commercially, active hubs. So the technician, those who are working in data centers, they have tremendous pressure delivering the KPIs and SLAs, and they post the duty, they go meet other guys, those who are operating conventional buildings. So retaining these employees, experienced guy, in that very easily poachable areas is a second challenge. So we have created a very in-house unique solutions of employee, we call it rewards and recognition, R&R. And obviously compliance is one requirement. We can't do the non-compliance in terms of their salaries, minimum wage scales, PFSI and all these things. I'm not going to put some light on that, but a very standard one. But rewards and recognition and continuous training with the help of OEMs. We are creating this ecosystem, but we are a long road ahead for us because the demand is now gone up. We have deployed approximately 1,200 resources in our DC operation. With Vertif is our one key partners, and Schneider's and couple of direct customers. So we are creating this very robust ecosystem for supplying a talented and relevant experience DC expert, blue collar employees I'm talking about. I'm not bothered about the manager and above, shift engineer, shift supervisors, and MST DG operator. There is a challenge. So we are looking for some kind of trainings, enhancement, some kind of basically employee retainment program, and try to cope up this demand, geared up for this. And we have excellent, I would say, track and record, customer satisfaction index in our company. It is out of 4 is 3.8 now. And we take very neutral feedback. It has been managed by our quality and compliance team. So that's where we are. So I'm looking that there is a huge expectation from the facility management company to go into technical side. Cleaning, maintaining, gardening, landscaping, pest controls, these are aspects. But when it comes to technical, any microsecond disruptions, any key parameter disruption is having a catastrophic effect on the DC operations. So we have to be very precise in that part. That's the reason employee hiring and retainer and the training is very essential. Yeah.
Thank you, Manoj. So Mr. Richi Mittal, now you have been in HV industry for 40 years, and I am also you stepping into the data center, and you have done already, you have experienced a couple of projects. So can you just 1 minute or 2 minutes you can be able to share your experience overall, so, positives and negatives?
No, I'll only say that, in any data center, cooling is something which is very, very important. And I think that is where the whole power, we talk of PU, CU, you know, everything boils down to power. And the power maximum is consumed by our fraternity, which is HVAC. So there are so many technologies which are coming in, like we mentioned about liquid cooling, immersible cooling, which is a old technology, but it has some challenges. I don't know why it is not coming in, but yes, there are challenges. As you mentioned, 80 to 20% could be, 80% could be liquid, 20% could be, has to be with air because of the components. So there are a lot of challenges, I would say, and every data center, and as the density of racks are going up, the challenges are going up. And I believe that I think in time to come, because of power, liquid cooling and the immersible cooling would be the only solution in time to come.
Thank you. So I think we have small time because we have 15 minutes. So we wanted to also cover up the entire sustainability aspect of it, but we will touch upon it, not we'll get into a detail. But when we talk about sustainability, because this is a very, very important topic on how we are driving different initiatives around environmental sustainability, what we have in place in terms of standards, in terms of policies, in terms of government support. I think I will go back to Jay Balan in terms of sharing your experience in terms of what you are getting as a part of policies and support from the government, and even standards which is available in the industry, how beneficial it is.
Sure. Thanks for, I mean, this is the sustainability, I mean, since yesterday we have been talking about. And because this is a need of our, as Mr. Chetan Solanki ji yesterday, I mean, given a kind of a thought to, I mean, inspiration to the topic. And so, while talking about government policy and other things, I thought after listening to Mr. Solanki's presentation, I thought it's my moral responsibility that let me, I mean, I take what I do as an individual and as an organization, we as, then, come to the topic of policies. So that reminds me, about 10 years back when I was having a discussion with a consultant for a data center design in Chennai. And that was the time, most of the time, I'm talking about 2010, most of the data center used to be in water-cooled chiller, used to operate, right? And the consultant came with the design of water-cooled chiller, and this is what you go for, design it. So, but we know that we are, as an individual, we are responsible to make sure that, we need to, maintain have water. We can't, because to bring some new technology, just, consume water is not going to help and not going to be sustained for long. So that was the day I still remember that, I said, no, we will not talk about water-cooled chiller because the industry is yet to evolve a lot, and we have to break the water-cooled chiller here, and then we moved on to data center and the air-cooled chiller. And moving to me as an individual, I mean further as an organization, we at a Princeton Digital Group. For us, the sustainability, it doesn't just remain a food, tick box in any of the, as an organization tick box. It starts from, the procurement. So, when we release a tender for hundreds of crores to the partners, all the OEMs, and we know for us, the safety and sustainability is a, that contributes a major role of selecting any partners while we work with this. But that's a need we thought that's, if until as we drive, because that's the organization we wanted to make sure that we take responsibility to drive the sustainability, because we consume good amount of energy, okay? And not only that, we also, released our sustainability report recently in this year, in May. And as usual, you might be seeing that, we report scope 1, scope 2, but in this last report, we also covered scope 3. So that indicates how an organization is becoming a transparency and accountability to drive the sustainability. Having said that, obviously, to continue the drive of sustainability, we are, what are the policy we have in data center right now, and what are the challenge and what we look for further. So, as an organization, as a country whole, we have huge amount of wind and renewable energies, either in the form of wind or in the form of, hydro or solar. But, state to state, the policy differs, okay? some states where, like some of southern states, you can consume the 100% renewable energy as whatever you consume in a data center. Whereas in Maharashtra, the policy where we have data center, major data center in Maharashtra, it doesn't permit so. So you have limitations of consuming the 100% what you consume from a solar. There is a restriction. So hopefully, I am sure the government and maybe the forum like ISHRAE will help us to get that thing evolved so that we, as we utilize the enhanced utilization of renewable energy and so on. Further, as we talk about the Bureau of Energy Efficiency talked about, we nowadays started seeing that the home air conditioner, the set point is getting increased. But when it comes to data center, while hyperscale customers are tuned to the new evolved or rise the temperature to in 29 and 30, even someone is talking about 35-degree ambient temperature for data hall, whereas the enterprise customer and the retail customer, the IT department, still yet to evolve. Probably a policy or kind of a support dictating that the data center, as a hardware, the minimum limitation, the temperature, holding should be evolved or elevated to at least 25, 26. So because that's how the ISHRAE or ISHRAE, the standards talks about. So that will also help us to drive the sustainability to next level, so that whatever we consume and try to neutralize with the carbon emission.
Thank you, Jaybalan. So because of shortage of time, I will just summarize the discussion, and if they allow, we'll go for a couple of questions. So what we look at overall data center is, this is growing. There are disruptions on the technology, and it is also throwing a lot of sustainability challenges, and where this forum can also contribute a lot, because whatever inefficiency or if you look at from the data center perspective, so around 40% of it consumed by cooling or HVAC system itself. So there is lot more things which this particular forum can contribute in the data center industry in bringing the efficiency and sustainability aspect of that part of it. Another aspect is on the sustainability, what we are doing overall, global versus local here. So there are certain sustainability benchmarks. We call it PUE, power usage effectiveness, water usage effectiveness, carbon usage effectiveness, recycling and reuse, and one more parameter I'm just missing out to it. When we look at global versus where do we stand today, so PUE, the average PUE in our part of the world and as well as other part of the world is 1.58, 1.6. So ideally it should be 1. Okay, so that's what it is. However, there are data centers which is having a PUE of 1.1 also. So I don't want to dwell into more into detail. Similarly, on the water usage aspect of it, fortunately in our part of the world we are using air-cooled chillers. So water usage effectiveness are much better as compared to the countries where the people are using evaporator or cooler-based systems. So normally those where the water effective usage, in our case it is around 0.5 liter per kilowatt hour. Where they are using the cooling towers, their effectiveness is more than 2 to 3 liters per kilowatt hour. Coming back to carbon usage effectiveness is more about emissions. So as of now, the more of the focus is more on power. How much power we are consuming from renewables, how much power we are consuming from the normal fossil fuel generation centers. So there is a big mandate from the customers of hyperscalers as well as the government also to use renewables in the data centers. So there is a key focus, there is a mandate and selection criteria also whenever they go for a data center aspect of it. Another aspect is we already have IGBC as a standard for data center which measures all the green initiatives on the data center front. This is already in place. Most of the data centers are being certified from that perspective, and they look at the construction of the building, all those parameters what I talked about, much elaborative aspect of it. So with this, I would like to conclude my remarks on this, and we are open for question answer if they allow.
Thank you very much. Thank you very much for a very insightful, I think, with the AI Tadka, the data center has possibly taken a much bigger limelight than what it was. And yesterday, Chetan Solanki ji mentioned AI is equal to kilowatt. You have actually underlined it 100 times today, all of you. So one of the questions which I had, and this is where, trying to look at an integral solution, and I'm talking especially with India and the struggle of power which we have for our normal GDP growth. I'm not sure whether anyone had factored in the data center growth as a part of our GDP growth in our infrastructure build-up. And I was just talking to Jaya, sorry, I'm picking up from our conversation yesterday. Astounding figure he mentioned to me, that a 15-kilometer stretch in Airoli area will have a 4 gigawatt power requirement by 2030. And whole of Greater Bombay does not have more than 2.5 gigawatt today. Come on. I mean, where are we sitting?
Want me to address?
No. I'm just saying, the humongous, and we are talking of grid power, this power, who is going to produce that power? And the classic advantage which we have, which in the India Cooling Action Plan has a not-in-kind technology, which is thermally activated, a classic case of tri-generation where you can produce gas-based power and the waste heat drives the cooling. And what I came to know, a 50 megawatt plant has only a requirement of over 6,000 tons of cooling. But it has a 75 megawatt backup of DG sets which don't run for maybe more than few hours. So why don't you actually have those white elephants removed and actually have horses which are the gas-based engines which run, give the waste heat, power the absorption cooling, and it will give surplus cooling from the waste heat for district cooling. So I don't think so. That would put the sustainable word very much in focus. Thank you so much.
Yeah, I'll take this question. Now, what I could understand, the problem statement, what you mentioned is perfectly summarized. In fact, I like to add another problem statement in Bombay, basically, since I come from Bombay. So, basically, you have talked about data center power, correct? But you have not talked about EV power requirement. See, basically, there will be increased EV adoption. Okay, so days to come, basically, even for charging the EV, okay, we require power. So as in today, if you talk about Bombay power requirement is around 4 gigawatt, approximately 4,000 megawatt. And presently, probably Bombay's data center, as on today I am talking about, is around 400 megawatt, approximately as of today. But you are right, actually, if I take the projection of 2030, which is a 5 megawatt, and out of 5 megawatt now, currently Bombay has a 40% proportion, 40 to 45% proportion out of the total India. So that goes to, if I take 40%, it goes to 2 gigawatt. Obviously 2 gigawatt, I can give an example, Dublin you must have heard actually, and there their government put a restriction that you cannot set up data center because their consumption was shooting up to 18% of the total requirement. So your point is perfectly right. So from the point of India perspective, definitely locating data center only to tier 1 cities, it's not sustainable. Currently what we are talking about, if you look at either it is in Bombay, then it is in Chennai, second comes in Chennai, okay. This has come because of the reasons actually, because of the reasons, historical reason that we have a cable landing station in Bombay and Chennai. And because of this actually all these business data centers are come up. But see, basically it was the latency was the issue that time to put the data center near to the coast. But now if you see, basically that is a fear. Now the data center can go inside because fiber through fiber, the speed is light speed. Okay, so latency, apart from very few applications, that is not a challenge. So we can put up the data center in the remote areas also now. Specifically, if you talk about this AI data center,
so sorry, I'm interrupting because time is running out. We can have offline discussions.
Sure. Okay, fine.
So thank you very much. What my response to you is, this industry is open for such kind of solutions. There has been a lot of talk on district cooling when we talk about data center parks and all. But I think the viability and all those stuff has to be worked out. So we are open for such solutions. Thank you for hearing such things with us. Thanks. We'll have an offline discussion also.
A huge round of applause for our panelists for sparing the time. I think it was a very thought-provoking conversation, and I hope, and we're sorry that we had to cut it, the Q&A. I'm sure our panelists are going to be around, so you can meet up with them and, continue the Q&A and the learning. To summarize this event first, I would like to ask Richie sir to kindly come at the center. I'd like the, yes.
Hello. I think Dr. NK has already summarized, so I'm not going to take much time on this. So.
Yes, sir. So we'll quickly felicitate. Firstly, we'll felicitate Singh Saab, the true data center guru, as he's called, for sparing the time and, of course, getting the best of our panel, asking them provoking questions. Next, Sudipta Sanyal sir. Mr. Manoj Kapil. Mr. Jay Balan. Mr. Pankaj Wadhwa. All the delegates, we can have a big round of applause. Our delegates, our panelists have given away their precious time for this. Mr. Alok Rajput. Mr. Amit Kakkar. And Mr. Frank Mewis. Lastly, I would like to call Mr. Manoj Chakravarti to kindly come up on stage and felicitate Richie sir for chairing this session. Thank you everyone. We can come together for a quick group picture and then we'll move on to the next track.